Hello viewers, welcome back. In our previous tutorial, I showed you how to use equation of a line to write a simple code to convert incoming signals into engineering units. In this tutorial, I will walk you through how to use the inbuilt FC, that's the scalar FC, to achieve the same results. Let's get started. Kindly subscribe if you've not done that already, and also press on the notification bell so that you always be notified whenever I upload new videos. Okay, so to do this we need to look for where exactly the scaling block is located. Okay, so we'll go into our catalog. The scaling block is always part of the standard library of step 7. So if you come to the standard library and then you open and then you move to TI-S7 converting blocks, you need to expand this and then you look for FC105, which is scale converter. I will insert a new network and then drag this particular scale converter here. Okay, good. So with the scale converter we can walk through quickly to look at the inputs signals that we need and then what exactly the outputs are. Okay, to get more help you can go and click on the help button and then you can click on and then you have this help written down nicely. But with this I will walk you through quickly. Input is basically the signal that is coming from field, that is the ADC converted signal. In terms of our equation, that is going to be our Y. And then we have the high limit for the conversion that you have to do. The high limit will take the engineering units that you want to convert this particular input signal into. So in our case, the example that we did in the previous tutorial, we were converting weight, which is between 0 to 100, to which was converted into electrical signal and then converted into numbers, which was between 0 to 27648. But in this case we need to specify the inputs here and then we will specify the maximum number, which is going to be 100.0 in this case, and then the minimum. Remember, the weight of the scale is between 0 to 100. So if the max is 100, then the minimum is 0. So 0.0. Okay. And then we have what we term as the bipolar. Basically, the bipolar input indicates that 1 is bipolar and then 2 is unipolar. Okay, bipolar indicates that your input signal coming in between 0 to your maximum ADC converted number, and then when you change from unipolar to bipolar, which means your number is between minus 27648 and then positive 27648. In our case, we'll be using the unipolar, so we need to make this section 0. Okay, and then we have this particular output is basically an error output. So whenever your conversion generates an error, you have an error code generated here, which you can use at other sections of your program to deduce whether the conversion that you've asked for went on well or not. Then the results of your conversion is what you get from this particular output. Great. So now let's configure this one quickly so that we can give it a test. Okay, so with the engineering values applied to this section, which is 100 and then 0, I will then apply the input signal that is coming in, which I will be entering from the simulator. So I'll use a memory location, so MW, let's say MW30, and then I need to specify a memory bit here as well. So maybe I can use 8 M8.0, and then output I'll write it to, let's say, a temp, or I will use a memory bit. We can check this is a real, so it's MD, which is memory double word. So I'll go for 34, and then the fault information is also a word. I can write it to MW, so I can go MW18. Okay, good. So I have our input signal coming in here, and then the scaling unit, the unit within which I want to scale the signal into, and then we have the bipolar or unipolar, and then the output, and then the error message. So I'll go to the simulator, click on save, download. Okay, so immediately we downloaded, you can see that the PLC has moved into stop mode, and there is a reason why we need to find out. Okay, so to diagnose this particular problem, we need to go back to the step 7 manager. We click on the schematic 300 station, we go to the hardware, and then in the hardware we need to go into online mode, and then we can right click on the PLC and then go to model information, and then in this window we go to diagnostics and buffer, and then we can see the reason why the PLC stopped: the FC not loaded. So this tells you that anytime you call a new FC from the library, you need to load that particular FC before you make use of it. Other than that, will send your PLC into stop mode. Okay, so we now understand why this happened. So we go offline, or we can close the online of the hardware, minimize this one, and then we go to the blocks, and then we need to re-download all these blocks again so that the new FC, which is FC105, will be downloaded as well. So you highlight and then you click on download. Yes to all. Yes, it's asking the CPU in stop mode. I say put it into run mode. Okay, so we'll now go back to the simulator again and see whether it's in run mode. Perfect, it's in run mode now. We can go to our program and then we can see that our block is now running. Good. Okay, so let's call our simulator and then we test or add 2 new memories. So for our input signal, it's memory word 30, and then for our output is memory double word 34. Okay, so with everything set, we can now change our values, which is input. So if I change it to 20,000, we are having 72, and this is the results of our previous code that we wrote with the equation of a line, and we can see that we are achieving the same results with that 20,000, and then here also the set point, sorry, the input signal 20,000. If I go to 2000, I get 7.2, and then if I go to the maximum value, which is 27648, I will get 100. Perfect. So with this FC, we are able to scale our signals from numbers into engineering unit, which is understandable by the operator and other users. Thank you for watching. See you in the next tutorial. Bye bye.